All right, how's everybody doing?
Okay.
So, sign-in sheet. I'm going to get rid of the signature line next week and just have the little circles. All right, questions? On PA1 or ODPs or Git. So let me clarify some things related to Git, just so we know what we're doing, because I kind of gave you the instructions for homework 1, but we don't want to just kind of blindly have to follow instructions. We want to know the reason why we're doing things. So let me give you a little bit better picture maybe of what's going on with Git. So this is our Linux server.
I think
It's off, yeah. Thanks. Thank you. This is our Linux server, or it could be your laptop, or it's whatever it is that you're using to develop your code that you want to push over into GitLab ultimately, right? For most of us, it's the Linux server, but it could be your own machine as well. And so when you want to work on a project, PA1, homework 2, PA5, whatever, generally you want to create a directory. Such as your home directory / PA1. Tilde just means your home directory. So here's my home directory. I could say make dir PA1. And I want to go into PA1, and there's nothing in there right now, okay? So you're going to edit your files. You're going to have file 1, file 2, file 3, or whatever. If it's PA1, you probably just got stick, but you've got some files in here, okay? And then at some point, you say git init. And what that does is, in this directory, it creates this little local repository. Okay, so git init causes this thing to appear. And you previously did homework 1, and you do that in a directory called hw1, and when you said git init, that created a little repository in here. All right, so you want to add your files to the repository. This is where you do git add and git commit. And those things cause your files to go into the repository.
what specifically is a repository?
It's a directory with structure associated with it. So let's all right, so there's my stick program. So I say git init, and I say git add stick, and I say git commit, and there's my comment for this version of my code. Okay, so I've checked it into the repository. What does that mean? If I do an ls-a, I have a directory called .git. Okay, that's technically your repository. There's a bunch of stuff in here. If I just say find out, here's all the files that are in this repository. It's a ton of stuff, right? I only checked in one file. But somewhere in here is my program, right? Probably in one of these objects. And a lot of it is not human readable. But the repository is just the collection of all this stuff that comprises a Git repo. So it's got the files themselves, it's got the change history, and so on and so forth. And different source code control systems do different things. Some systems just store differences from one version to another. Git, I believe, actually stores complete files rather than just differencing. So in my directory PA1, all I see is the code that I wrote. Okay, but underneath that is this hidden subdirectory that has, the copies of all this stuff. So if I say git log, it knows that on October 3rd, 11:05 and 27 seconds, I pushed a copy of this file, and I put a comment called not good. So the repository is associated in some sense with this directory. And this repository down here under homework 1 is associated with this homework 1 directory. So even though you previously did this in homework 1, if you make a new directory, PA1, and you don't say git init, you can't add stuff. Right? You have to create this directory, that's what git init does, and then you can add stuff by saying git add, git commit. Make sense so far? Yeah.
If someone hasn't done the subdirectories, how would they remove the .git directory?
So, like you're just completely done with it?
And then redo it for a subdirectory in...
So you can remove that with an rm command or an rmdir.
On the Linux server, it told me it couldn't.
Yeah, and you got to be really, really careful with this. But if you say rm-rf directory, that will remove the directory and everything underneath it. But you got to be super careful with that, right? Because if you do that in your home directory and you say rm-rf star, it will remove every file that you've made on the system without warning you. But to get rid of the .git file, right, you could say rm-rf.git. And as long as you're in the directory that you really want to be in, that'll work.
Thank you.
But I'll flag that with danger.
Use the subdirectories for the PA1 after I figure out how to copy my stick program to a subdirectory.
Right, so let's do that. All right, so I got all kinds of stuff in here, and it's not under git control. Okay, so I've got my stick program in here, and I say git init and git add stick and git commit. All right, but I'm sitting in my login directory, okay, and I wanted to be in a different directory. Okay, so make dir PA1. Or 224/PA1 or wherever you want it to be. Make your directory and then go into that directory. Okay, so I suggest copying instead of moving. Right now, my stick program is in my home directory, okay? .. means one level up. So my stick program is sitting in there. Here's what I'm going to do. Just copy ../stick to my current directory. And now in my PA1 directory, I've got a copy of stick. And now in my PA1 directory, I can say git init, git add, git commit. Yeah?
To reduce clutter, wouldn't you just move it?
You could move it, but if you move it in the wrong way, or if you move it into your PA1 and then something goes wrong while you're trying to put it into git, you might lose your only copy.
Okay.
So we're just making sure that we don't lose the original. This is just kind of a
Safety measure.
Safety measure philosophy / problem that I have, which is just worried that something's going to go wrong, right? I've got a copy of my program, it works great, this is what I want to turn in. I'm not going to get rid of that. I'm not going to get rid of it until I'm done with my class and I'm done with Clark and I've got my PhD and I'm retired. And then I'll go back and delete it. Okay?
That's a long time.
Yeah. So copy it in there. So now if I go in my home directory, right, yeah, I do have a stick. I also have a Git repository, okay? That doesn't do any harm, right? If you don't use it, it's not going to do any harm, but if you really want to get rid of it, rm-rf.git. If you say rm-rf space git, you lost all your files. Because dot is an abbreviation for your current directory, so it's saying remove all the files from my current directory on down, and then remove a file called git, and it'll say no such file git. But meanwhile, all your files have been wiped out. So that's a super dangerous command. but you removed Git. So a cleaner way is to rmdir.git, but it's going to say that it's not empty, so it can't do that. And I don't know if you can force that. Nope. So you can go into .git and try to remove things from there, but yeah. So just type carefully.
Thank you.
Yeah.
For PA1, do we need to submit anything on Canvas, or do we just need to make a reporter on the?
Just make me a reporter on GitLab, and that's all you need. You don't need to do anything on Canvas.
Wait, so why do you need to do the rm-rf dot and then the dot git? Why can't you just do the like git init to make a new git repository?
So the scenario here was that in your home directory, you inadvertently said git init, right, as opposed to a subdirectory. Now I can go into a subdirectory and I can say git init, and that makes this repository, but there's still a .git sitting in my home directory. So if that bothers you, if you want to get rid of it, that's what the rm-rf does. But it doesn't do any harm. It's a hidden file. It's not taking a lot of space. You'll never see it, and unless you want to do git stuff in your home directory, it's okay to just leave it there. But you can get rid of it if you like also. All right, so this is all local Git, right? You make a repository, and then you can add commit, add commit, add commit. So meanwhile, over here, we've got gitlab.com. And when you say git remote add origin blah 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 blah, what that does is it creates a repository over here in GitLab, and it kind of connects these two. Connects them in such a way that when you say git push origin master, what you have over here will be used to update this remote repository. And that's just for this repository, right? If I want to push this repository into GitLab, I have to do git remote add. And that makes a repository over here. And then when I say git push, right, that'll push that stuff over there.
When you say that it updates it, does it change what is on GitLab to be what is in the repository?
It changes what's over here to match what's back here.
Okay, so let's say that you upload a file,
Mm-hmm.
and then you delete that file in your repository, and then you update the...
So deleting is a different story, right? And in general, try not to delete. If you want to delete a file from here, you actually have to say git space rm space file name. Okay, and that deletes it, because if you just say remove a file, it removes it from here, but it's still sitting in the repository. Right, so git rm actually removes from the repository as well as from up here. If you don't do that, you can get into trouble.
Once you do that and then update it, though...
And then you update it, then it'll be deleted from here.
Gotcha.
But not forgotten, right? You can still go back to a version that you pushed over before it was deleted, and you can get it back.
Does git rm remove the actual file?
I believe so. Right, so yeah, it removes the file, then it removes it from the repo. The danger, one of the dangers is if you just remove a file from here, but it's still in the repository, and then at some point you try to pull some, and then you make a new copy of this file, right? And then you try to push that over, sometimes it will complain about versions. It'll say that the version over here is basically too old, right? And you're trying to push something that's going to confuse it. If you get totally sideways and everything is completely messed up, right? Easiest thing to do, as long as you've got all your stuff here, just hop onto GitLab, delete that repository, right? And just go back and do the git remote add and the git push. You probably don't even need the git remote add again. Just do the git push. Or, you know, just go into a new directory, copy your files over, do a git init, do your git add, git commit, and git push. Right? You can always start over. But again, if I was going to do that, instead of deleting this directory, I would just rename it. I'd move PA1 to PA1 old. Then I'd make a directory PA1, go into there, copy the stuff from PA1 old to there, do the git init, git remote add, and then just git add, git commit, git push. And a few people have come by in this situation, and that's exactly what we've done, is just sort of make a new repository, start over. Just don't forget, you've always got, you know, what you have on the server here or on your laptop. That's still there. Just leave it around, and you can always start over again on GitLab. The problem with deleting the repository and starting over is you lose the version history, right? Which is another reason you just want to rename the old directory instead of just getting rid of it. Because if you got to go back to, you know, this worked great last night and then I broke it, you can go back to an older version if you've got everything checked in. All right, other questions? And Git is one of those things that once you've got it set up, you don't really have to think about most of this, right? And every time that I teach this course, I have to relearn a lot of this because I don't deal with it, right? I have all this stuff bundled into shortcuts. I have a machine over in Virginia Tech that I do research on, and I just say go, and everything gets pushed over, right? And it's doing all this stuff, but I don't even think about it because I set it up once, and then I just say go, and it pushes everything over and keeps it all synced up. And when I want to log in there, I just say VT. I don't even know what my account is anymore, right? So it becomes second nature at some point. All right, so ODP 408 is posted, and this is due tomorrow morning, along with your stick program. I'm going to show you how to write the code for ODP 408. So this is like the first ODP. The real point here is not being able to write the C code, it's being able to compile it and being able to assess it and that sort of stuff. So it's just kind of a warm-up to doing ODPs that are C programs instead of shell scripts. And this is what most of our subsequent ODPs will entail, is writing C code, ultimately functions in C instead of scripts. So ODP 408 is a program that takes a command line argument. So you're going to type the name of your program, space, and an argument. The command line argument should be a double, and your program's going to print the square root of it. So it's a square root program. And I put down the important gotchas here. You got to do this on linux.engrcs.com, and you got to use the GCC command without any other modifiers, okay, if you want to get the full assessment. You have to use the -lm switch when you compile to link with the math library. You have to include math.h. Make sure your numbers are doubles, not floats. And you can assume that the command line argument is present and it's a real number and it's not negative. So no error checking. Okay, if someone runs your code incorrectly, it can blow up, and that's fine. To convert the arguments, so arguments to C are always strings. They're character arrays terminated with a null. To convert that argument to a number so we can take the square root, we're going to use scanf with a %lf as the conversion. We'll use the square root function to find the square root, and then we'll print it out with a %lf\n. So let's hop over to Linux. And let's make a my square root. The network is lagging. So we're going to include standard IO, we're going to include math.h. That tells it what square root is. Tells it that it takes a double, returns a double. I'll just do an int. All right, so integer main, and since we have command line arguments, we got to do the argc argv thing. So we're going to talk more about this tomorrow and next week. We'll start talking about C programming in general. But really quick reminder, argc is going to tell you how many command line arguments there are. So if I say my square root, this is fun, I've got 4 things on the command line. My square root, this is fun. 4 things separated by spaces, argc will be equal to 4. argv is an array of strings. argv bracket 0 would be the string my square root. argv bracket 1 would be the string this, bracket 2 would be is, bracket 3 would be fun. argv bracket 4 technically does not exist. If I try to use it, I'm going to segfault. But we don't have to worry about any of that here because we know that we have one command line argument. So let's say read command line argument and print its square root. So I'm going to make a double called number. And I want to read the first command line argument and change it into this double. So this is what scanf does for us. Scanf, we put in the string that we want to convert, which is going to be argv bracket 1 is the first command line argument. argv bracket 0 is the name of your program. So argv bracket 1 is the first command line argument. The hint in the assignment says use a %lf. And then the last argument is what we want to scan into, which is number. And remember, you always have to put the ampersand in front of ints and floats and doubles in cars. So we'll spend a lot of time reviewing scanf later. And then we're supposed to print it with a %lf followed by a \n. And let's print the square root of number. And I don't have to return anything in particular, but I'll just return a 0 because I said main was an int function. So all the action is really just 2 lines. Convert argv1 into a double called number and then print the square root of that number. So compile it, gcc-o my square root.c. Undefined reference to square root. It doesn't know what square root is. I didn't write the square root function, and it doesn't know about the square root function. So this is what this -lm switch will do for you. That says link in, and m is a shortcut for a library called libm.a, at least it used to be. And so in a particular directory, typically /user/lib, it'll find this math library, which hopefully includes a definition of the function square root. Now it builds correctly. So now I can say my square root 25, and it prints out a 5. My square root 101 is a little more than 10. Now if I say my square root -1, I get negative, not a number. Right? But it says you can assume that the argument is given and it's non-negative and it's real. So my square root haha, and it gives me 0, but you're not allowed to put in haha. And if I don't put in an argument at all, I get a segfault, but that's okay. We can assume there's an argument there. Alright, so I should be able to assess my square root.c, grade it, and 3 tests, 10 out of 10 on each, we're good to go. So on the Linux server, under the resources on top, there's code from lectures. So if you click through to that, there's a copy of my square root. So you can type it in from there, or you can write it yourself. But again, the thing I'm interested in is making sure that you can compile it, well, that you can create the file, you can compile it with a -LM switch, it runs correctly, and then you can assess it. So this will be the only ODP left for this week. I won't give you one tomorrow. We'll start in on the ODPs again next week, and we'll start embellishing this with some error checking. All right, questions on that?
Can you go over the double asterisk syntax for the ArcV?
Go over what it means, or?
Yeah.
So, and we will talk more about this later, but basically if you say character C is a character. It's just one 8-bit thing, right? If you say character *S, S is a pointer to a character. That's what we call a string. Okay, it's basically an array of characters. But it's really an array. It's a string, but it's really an array of car. If you say integer *A, that's an array of int, right? If we say float *B, that's an array of float. Okay, what if I say car *S? That's an array of car *, and car * is a string. So car ** argv says argv is an array of strings. So argv bracket 0 or bracket 2 or bracket 1, each of these is a car *, it's a string.
So if you did like RV brackets and then brackets, that would be like the first letter.
That would be the first letter of the first string, for example. Yeah, exactly. And so when you run a command in a C program, program name, put in a bunch of things separated by spaces, before your program starts executing, the shell picks off those words that come after it separated by spaces, and then it basically runs your main program as if it was a function. It is a function, and the arguments it passes to it are that collection of strings. So this is the first string, second string, third string. So it's a perhaps goofy but effective way of passing and retrieving command line arguments to C programs. When we get to Java, we forget about all that. We just have a plain old array, and we just have array bracket 0, array bracket 1 to get the arguments. In Bash, we just say $1, $2. But C makes us do some work. All right, other questions, comments? All right, let's play a little more with algorithms and code and pseudocode. So we talked about structure charts yesterday, where you could have a series of sequential statements like that, and we could do conditionals and say what to do if some condition is true or false. And then we had loops. So while condition 2, and we can list statements in here that we want to do, and so on. And I made a caveat which was no break statement. If you want to break out of a loop, you'd like to code the condition in the while statement so that it breaks out when it needs to break out effectively. So I want to give you a program to work on. I'm going to let you work on this in groups of 2 if you like, or you can work by yourself, but you can find someone sitting near you and work on this as a group. So yesterday we wrote code that let you input numbers until you put in a 0, right? And then it printed out the average of the numbers, right? Is that what we did?
Yeah.
Okay, good. So what I want you to do today is input integers from the user. Don't store them, because we don't know how many they're going to type in. It could be 5, it could be 5 billion. So we're just going to read numbers from the user until the user enters a 0. So they could be typing in positive numbers, negative numbers. Eventually they'll type in a 0. Once they've typed in a 0, then I would like you to print the maximum and the minimum of all the numbers that they typed in, not including 0. So if they type 5, 10, 15, and then 0, the max is 15, the min is 5. Right? Don't count the 0. So just read numbers from the user until they put in a 0, and then print out the largest and smallest number that they put in. And I want you to think about an algorithm for doing that, and then write a structure diagram that shows your algorithm. And we'll take about 10 minutes to do that. And I'll pass out some paper. Do you need paper up here?
Yeah.
Can I see that piece of paper? Nick, I heard what you're doing after school today.
What?
I heard what you're doing after school today.
Yeah.
I wish I wasn't doing a ton of homework.
Yeah. It's going to be crazy.
How much are tickets?
They start at 60. They go up to a few hundred.
Where? Oh, okay.
So
Where
is that Left Bank?
What's it called?
The Left Bank?
The Left Bank?
By the Motor Center?
By the Motor Center.
Yeah.
Can anyone get tickets?
Yeah, they had tickets a few days ago, last I looked.
And it's yours, like, not
Yeah.
yours, but it's like you have your own segment.
I got one piece I'm showing.
Just one piece?
Yeah.
Okay.
So there's 29 designers.
Is this
And
what's happening on the 6th? Wait, when was it?
Today.
this is this thing that I'm doing.
Oh, okay.
Yeah.
Sorry, I thought you were, I remember in 270 you were saying something about
Yeah.
there is a day in December or something.
Oh, no. And if you're done with this already, you can turn it in and I'll start looking at it, but we'll take a few more minutes to work on this.
Do you want one per person or one?
No, you can do one per group.
Did you have to do error checking or no?
Do what?
Did we have to do error checking on that or no?
No.
Oh, that's in that law. Yeah, I was just asking about the force. Before you said that, you have
More than 5.
I'm not going to do a single one.
Okay, here we
My code has bugs,
That's okay.
but it'll do it.
Bugs are important.
So the one it would be too complicated to try and write it out.
Yeah.
To like get the error checking out.
That's okay.
And then it goes down and then it says, one of them is a 10.
Well, so this,
You know
well, in this case, wait.
Mine is nicer.
So they put a number of yeah. Mine's a whole line low. It is W's kind of weird out for it. I call them low and high. Like if the number is less than low,
All right, so let's take another minute and then go ahead and pass in what you have, if you want me to look at it.
Even if I use less than that's a good idea. Do nothing. Could left it blank, but I like yo dog. Yeah. Something super sloppy. I'm happy to go here. Go to here, right? First one? Yeah, but he's gonna keep logging things. And then once he hits 0, it's gonna stop logging things, and it's gonna organize that. And I don't know. Everyone will have a lot more in-depth. What? With our name? Everyone will have a lot more in-depth. Read number and check this out. Still working in math. I mean, you know, sometimes.
Yeah, so again, if you don't want me to show it on the projector, say do not show on the top.
All right.
Otherwise, it's fair game.
But do you want us to put our names anyway? If we put do not show?
If you don't say do not show, I'm going to put it up here. So if you don't want your name shown, don't put your name.
Oh, okay. We could just not put our name on
Yeah.
it, and you could show it.
Yeah.
For the side game, I was thinking about what I could do for it just to make it more fun.
Mhm.
I thought about putting like a P parameter or something, where if you use the command line argument, you wouldn't be just like it would like check all the conditions and everything.
Okay. Yeah. Cool.
We'll like add that to the ending. Then,
Okay.
like, try again with the P command.
Yeah, yeah.
See if it wins.
Cool. All right. Go ahead and pass forward what you got.
Okay. What do you end up doing?
Yeah. I mean, you can do 2 if you want.
Oh, right. Let's see.
I just want to kind of get a sampling of where people are.
So yeah, you did kind of the same thing. We did. I did a while loop, but yeah, I did if it's true, then go 2, right? And then if it's false, then well, if it's true, it should start comparing. If it's false, just keep going. Oh yeah. I stopped it. And you can't see that before. Never played it. It's like Risk, but like yeah. I've heard a lot about it. Tony, do you remember? There was a guy in Bridge matches September. Yeah, Love was changing the mind this year.
It wasn't like this young years before. Yeah. And like
It'll give you a point,
but
if you don't name the band.
like accessing it.
Yeah.
All right. So let's look at some versions of this. So here's one version. So it starts off read a number. Okay, so we're not storing our numbers in an array. So it looks like everybody figured out you got to figure out the max and min as you're getting the numbers, right? You can't just read the numbers and then calculate that later. So read the numbers, and the first number that you read in, let's set that as the current max and min. Because so far, that's the largest number you've seen, that's the smallest number you've seen. So we set it off to be that initially. And then we enter a loop similar to what we were doing the other day, which is if the number is not 0, we're going to continue with the loop. So what do? Compare it to the min. If it's smaller than the min, set the min equal to that number. and compare it to the max, and if it's bigger than the max, set the max equal to that number. And then again, at the bottom of the loop, read the number and go back up to the top. So this is the structure that we keep bumping into, where we want to kind of do this until the number is equal to 0. But if the number is equal to 0, we need to skip all this stuff. So do the read at the bottom and check the condition at the top of the while loop. And to make that work, you need to do one of those reads before you get into the loop. Okay, this is similar to stuff that you probably bumped into in PA1. All right. I had one where max was originally set to negative infinity and min was set to positive infinity. And some systems have a well-defined notion of positive infinity and negative infinity. And if that's the case, for example, doubles under Java, you can actually say negative infinity, and that's a very, very small number, and every number is bigger than negative infinity. And so if you set the max to negative infinity, the first number you read will automatically become your new max, which is kind of a nice trick. So yeah, there's a positive infinity, negative infinity example. The other thing in this example is this person used a flag. They created a variable called stopped, and they set it to be false originally. It's pseudocode, so we can have binary variables. And then their while loop is while stopped is false. In other words, while we're not ready to stop, read an input from the user. If the input is 0, set stopped equal to true, and just go back to the top of the loop. If the input's not 0, then compare the input to the max, and if it's bigger, set the max. If it's smaller than the min, set the min, and go back to the top of the loop. Very, very clear looking at this what's going to happen. If the input's 0, we're just going to set that flag. We're not going to do anything else. Right? If the input's not 0, we're not going to touch the flag, but we're going to adjust the max and the min. Not so obvious when you're looking at bash code, right? Because this is all nested and there's weird things and statements inside statements, right? But from here, it's pretty easy to see. You got two options, either this or that, right? And then you take this and you write the bash code to mimic this, and if it's not working, you start stepping through one line at a time and figure out where it's doing something different from there. So different approaches. Here's one other one. We started off with I equal to 0, and this whole while loop is while I is 0. Read A. If A is 0, set the flag. Otherwise, do the max and the min adjustment. Right? Same thing we just saw. All right. So I think people have the idea of this, which is good. So think about this. Ask questions next time. So my plan for tomorrow is to start talking about. I want to touch up on some Linux stuff. I want to talk about shortcuts for working in the Linux environment, making things more efficient, and then we're going to start switching gears and talk about C. And we'll go through command line arguments and scanf and all that stuff. And we'll talk about PA2, which is going to be your stick game, but in C instead of bash. Yeah.
Shortcuts in Vi, like how to move around quickly.
Yeah, I have Vi on my list, so we'll try to do that tomorrow or Monday.